Let's understand speed in this short session. Now, if you recall from your MYP or GCSE, IGCSE years, you would remember that speed was defined as distance over time. However, since you're now in IB Diploma or AS levels, so in this case, the speed is not going to be defined that way. Rather, you would say that speed is the rate of change in distance. That is going to be the correct definition now. But what does that actually mean? Let's understand the meaning of speed from the given definition using the graph that we have. You can see that it's a graph of distance in meters over time in seconds. Now you can see that the distance changes linearly till the 20th second, a linear graph. Then another linear graph, but this line is flat. This is parallel to the time axis from 28th to 30th second. However, beyond 30 seconds, that is from 30th second to the 60th second, the graph is non-linear. So let's understand how we can find speed in all these three different sections. Let's focus on the definition once again. It says it's the rate of change in distance. Now understand, if you have for any graph where you have a y, you have a x, and you have the graph like this. For any graph, the rate of change in y over x simply means the gradient of the graph. That's it. It simply means the gradient of the graph. Now, if you want to understand intuitively, then how do you find the speed? You basically choose a small interval of time, right? From 1 seconds to 5 seconds, or you can go down as low as a nanosecond. So you choose a specific time interval and you measure what is the change in distance in that time interval. So what you actually do is you do speed v is given by v is basically change in distance. Let's suppose the distance is in x, or if you have trouble with x, then I would rather take it as L. Let's suppose the distance covered is given by L. So a change in distance is delta L and a change in time is delta T. So that ratio is going to give you the speed. Yes or no? But this particular formula does not explain everything. That's why I am going to have to break it down, right? We'll understand that with the help of a graph. Now, imagine, as I said, if you have to find the rate of change in y over x, it's simply the gradient of the graph. So all you have to do is to find the gradient of the graph at different points. If whenever you want to find the rate of change at a given point, let's suppose here, you're gonna have to find the rate of change at that corresponding point. What is the gradient of the graph at that exact point? It's basically the gradient of the tangent to the graph at that specific point. Yes. So similarly, if you want to find the speed, for example, let's suppose you want to find the speed of the particle at, let's suppose, 40th second. So you're gonna have to choose this point and you're gonna have to draw a tangent to the graph, right? And then here the gradient of tangent is gonna be your true speed. That's the exact speed that the particle has at that particular precise moment. However, there is another way you can find speed, but that is not the true speed. That will be the, what do you say, the average speed. Imagine the question asks you to find the average speed between the 20th second and the 50th second. So you're gonna have to choose the 2 points, one point as 20, one point at 50. Then you're gonna have to draw a straight line. So you're gonna have to draw a straight line like this. Now that we are done with the straight line, we understand this is not a tangent anymore. This is a chord. So gradient of chord is the average speed. So there are two types of speed that you will be dealing with. One is the average speed, which may not be the exact speed at a particular instant. It will be the average speed. And one will be the true speed, which is the exact speed at a given instant. So what's the difference? The true speed is the gradient of the tangent drawn at that precise point. But the average speed is the chord that connects two different time intervals. And if you find the gradient of that chord, that's what you call the average speed, right? So now, in order for this to reflect in our formula, we will say the average speed is given by delta L by delta T. Well, here you don't have to be specific because according to delta T, the corresponding delta L will be determined from the graph. So that's the average. But if you want to find the true, or as some call it, instantaneous speed, then it's going to be the same definition, right? But you also have to emphasize on the fact that the time interval is going to be extremely small. Some also write it as approaching to zero. It should not, the time interval should not be zero, of course. It will be very small, like a nanosecond, right? A very, very small time interval, not exactly zero, but very close to zero. If you take the time interval that small, then the speed that you get from this formula will be the true speed, which will be the which will correspond to the tangent to the graph. But in general, the average is going to correspond to the chord of a graph, right? So understand, a chord becomes a tangent when you take the interval approximately zero. As you can see in this graph, imagine if I choose one instant as let's focus once again here, right? Let's focus once again here. So if you choose this point, right, at 40 seconds, now let's suppose I choose the next interval, the next point in time at 50 seconds. So the time interval is 10 seconds, right? So in this case, still what you have is a chord, yes or no? Now understand, my base time is 40 seconds. That's where I want to find the speed, but the next instant is not 50 seconds. It's going to be extremely small. That means the next instant of time will be very, very close to 40 seconds. It will be at, let's say, 40.0000000, as many zeros as you can find, then one. So it's about 40.000000001 seconds. In that case, the next point is going to be just close to your 40 seconds, and that's when the chord becomes a tangent, right? This is the chord and this is the tangent. Now understand, for the chord, delta t can be anything. It's it could have an what do you say, an arbitrary value. But when it comes to true speed, which corresponds to the tangent, here your delta t has to be extremely small, so that the chord becomes a tangent. Now, if it's a tangent you're drawing, you're finding true speed. If it's a chord that you're drawing, you're trying to find the average speed. And that's exactly what speed is. But you need to understand, the question in the exam may be asking for the average speed between two given instants of time, or it may be asking you to find the true speed at a particular instant. Now you have to pay attention to the those details and draw your tangent or chord accordingly on the graph, and then you have to evaluate its gradient. And that's it for now.